Hi everyone, welcome to Daniela Todd, Daniel Yeager, and Richard Gesvenhausen's presentation on nanoencapsulated aerogels. I hope you guys enjoy it. Before I begin this presentation, I would like to start off with a quote by Tim O'Reilly, who is the founder of O'Reilly Media, which is formerly known as O'Reilly and Associates. He's also a big supporter of the free software and open source movement. Tim said that what new technology does is create new opportunities to do a job that customers want done. Since its inception in 1958, NASA has continually pushed the boundaries of what is scientifically possible both on Earth and in space. Employees at NASA work tirelessly to bring creative innovations to the forefront of science, improving the safety and quality of processes and products that Americans will use in the future. Thomas Sullivan's patent and development of nanoencapsulated aerogel is one such invention. Sullivan has developed a polymer-coated aerogel that is less fragile than its predecessors while keeping its lightweight and thermal stability. The encapsulation of the aerogel serves to strengthen the three-dimensional mesh of the aerogel, eliminating fractures that occur with untreated aerogels. Prior to working with NASA, Sullivan worked for 8 years with DuPont as a research chemist in process development. Sullivan has been employed with NASA since 1989. He previously worked as a SHFH element scientist, and now he holds the position of senior scientist at the Johnson Space Center. Over his 20-plus year career with NASA, Sullivan has worked in many capacities, such as the in situ research utilization, management of U.S. science done on the Russian Mir space station, research and development for future manned spacecraft, and also, as mentioned earlier, the SHFH element scientist for space, human factors, and habitability. Sullivan first started the technology of nanoencapsulated aerogels while in a team meeting at NASA as team members were discussing different ways to insulate spacesuits. The extremes of space called for a material that was lightweight, insular, and extremely strong. Sullivan, having a background as a chemist, began to explore this technology further in 2001. It took about 4 to 5 years for him to receive his first patent. Sullivan currently holds 2 patents on this technology. The first patent is 7270851, and the second patent is 8039099. I will discuss the difference between the two later in the presentation. The technology is not ready for use in space, but could be utilized in the consumer market with more development. Patent number 7270851 was filed on November 4, 2004, and was issued on September 18, 2007. Sullivan titled this patent Method for Nanoencapsulation of Aerogels and Nanoencapsulated Aerogels Produced by Such Method. Patent number 8039099 was filed on August 31, 2007, and was issued on October 18, 2011. Sullivan titled this patent Nanoencapsulated Aerogels Produced by a Monomer Vapor Disposition and Polymerization. One patent covers the innovation of the encapsulation, and the other patent protects the method for nanoencapsulation. There is a very small distinction between the two patents, but both were necessary to protect both the invention and the process for Sullivan and NASA in the future. What it really boils down to is patent number 7270851 relates to a method for nanoencapsulating aerogels, and patent number 8039099 relates to a composition of the matter for nanoencapsulated aerogels. Because aerogels tend to be very delicate, the application provides a method for increasing the mechanical strength of aerogels. The polymer coats the aerogel in gas form and through part of the process adheres to the walls of the aerogel. Since the polymer is merely coating the walls of the aerogel and not completely filling in the spaces, the aerogel retains its light weight. Once the polymer adheres to the lining, it becomes rigid, giving the lightweight aerogel a new rigid toughness. Aerogels are usually produced by drying a suitable gel. Aerogels can be either inorganic or organic. Organic aerogels are derived from diverse starting materials. Inorganic aerogels are colloidal components. The most popular colloidal component is silicon dioxide or silica. Aerogels typically produces a nanostructure that has extremely small interconnected particles. The interconnected particles produce solid materials comprising the pores. The nanostructure of the aerogel allows them to have unusual acoustic, optical, thermal, and mechanical properties. In terms of functionality, aerogels has a lot to offer. They can pack tremendous surface into a small volume, which means they have a high surface to volume ratio. Aerogels backbones can be made of many different substances, providing tremendous chemical flexibility. They can frequently made through ambient temperatures, benchtop processes, and the open pore network of aerogels enables movement to stuff through the aerogels, providing avenues for getting things you might want to detect or absorb to the functional groups that will sense or absorb them. Making an aerogel where you can functionalize the surface has 3 points in the process to follow. Each of the 3 points has advantages and disadvantages. The first of the 3 points is functionalizing during gelation. In this process, special reactive monomers are included in the sol gel process used to produce the gel precursor. This results in a gel network with special chemical groups poking out of its struts. The advantage of this process is simple and it reduces numbers of steps. The disadvantage of functionalizing during gelation is it can be very tricky to develop a gel recipe that incorporates special reactive molecules as they change pH, gel time, and chemical pathways needed to form the gel, and themselves may react with chemical and solvents needed to form the gel. The second of the 3 points is functionalizing after gelation. In this process, a gel has formed and special reactive molecules can be introduced into the gel's pore network by diffusion. The chemical reaction between molecules in the gel backbone can be initiated once the molecules find their way into the pore network. The advantages of this process ensures proper functionalization of the gel backbone, allows greatest flexibility and control over how functionalization happens. The disadvantage of functionalizing after gelation involves diffusion-limited infiltration, which is slow and ill-suited for large, low aspect ratio monoliths, such as cubes and spheres. It also may require exchange of pore fluid for a solvent that will not react with functionalizing agents. The third and final point in the process is functionalizing after supercritical drying. This process is similar to the process of functionalizing of a wet gel after gelation, except for the reactive molecules are introduced as a vapor into the pore network of aerogels. The vaporous reactive molecule diffuses its way through the dry pore network and finds its way to the surface group on the strut in the pore network, where a chemical reaction can be initiated, result in the formation of special functional groups on the surface of the strut. The advantage of this process is that it eliminates tedious, slow solvent exchanges needed to functionalize after gelation and does not interfere with gel chemistry. The disadvantage of functionalizing after supercritical drying is that it is a diffusion-limited process ill-suited for thick, low aspect ratios monoliths. Can be tricky to get reactive molecules into the aerogel pore network without invoking capillary collapse. May be difficult to get reactive molecules for functionalization into vaporous forms and oftentimes more hazardous than liquid-based processing.
Hi, my name is Daniel Yeager and I will be discussing the second portion of this presentation. I want to talk about a brief overview of our aerogel patent, some of its properties, and an introduction into our desired target industry. The process of nanoencapsulation gives our aerogel many benefits that a normal aerogel does not have. The first of these benefits is that there's actually a compositional change in the aerogel when it's encased in this polymer. It makes the aerogel extremely lightweight, more rigid, and less prone to breaking. Once encased in the polymer, the aerogel increases its acoustic and thermal insulation properties, gives it an ability to filter many gases and fluids, and there's a negligible weight increase once the polymer is installed. Aside from the insulation, the acoustic and thermal insulation, one of the other key properties that the aerogel gains is that it becomes extremely strong, where 1 inch of this new nanoencapsulated aerogel is equal to about 10 inches of fiberglass. It's also extremely versatile. It can be preformed into many shapes or machined, which means it can be incorporated into just about any product we could think about. Now, there are pretty obvious applications of this aerogel, especially when it comes to the acoustic and thermal insulation properties. Acoustically, soundproofing would be very easy to do. Thermally, any sort of heat transfer protection would be possible. Our report focuses on using the thermal insulation properties of this aerogel to incorporate into clothing, which we'll get into in a little bit. But I think one property that is not quite as obvious is that once the aerogel goes through this encapsulation process, it actually becomes a very lightweight cushion, high-performance cushion that can protect from impact without and absorb shock without rebounding any of that impact into the material it's protecting. Here you can see a few images that illustrate the thermal insulation properties that I've been talking about. The two images on the left, you can see that blue solid is the aerogel, where the matches in the flower are being protected from the flame underneath by a very thin layer. If it was a normal aerogel, that flame would go right through. If it were many different materials, that flame would go right through and start to melt or set those matches on, either melt the flower or set the matches on fire. And on the right, you can see a close-up image of the actual aerogel. This number down here is 2 nanometers, so it's pretty small. And through the nanoencapsulation process, the polymer, it just coats the walls of all these crevices, which keeps the aerogel lightweight. If the polymer were to fill in all those areas, it wouldn't be light, it would be pretty heavy for the size it is. But since it just coats the walls, that's what gives it its lightweight, rigid property. Now, as I mentioned before, aerogels are commonly used in safety devices because they can minimize the force felt by an object due to an impact. Two graphs on the following page will show us the difference between the nanoencapsulated aerogel and just a normal polystyrene, such as styrofoam. Now, basically, they show that the improved strength of this aerogel technology can withstand greater impact, can absorb the force without rebounding, and can do it over a quicker time period. You can see the red line and the yellow line. The red line is our nanoencapsulated aerogel. The yellow line is just a normal polystyrene like styrofoam, and the green line is without any protection at all here. So you can see that the red line, our nanoencapsulated aerogel, it withstands the force, diminishes the force over a smaller time period right here. And it does it without rebounding. So here on the right, you can see that styrofoam will protect it about the same amount, but it rebounds quite a bit as well. Where the nanoencapsulated aerogel, it absorbs the impact without pushing it onto the object that it's protecting. Now for a brief overview of our target industry. Our desired market is the winter clothing market of the sports and outdoor suppliers. We think that if this aerogel technology was implemented as a high-tech clothing installation, it would give companies a new advantage in the winter wear market. New snow jackets could be made to be more insular without being bulky like current products on the market. Now, we know that there's already demand for products like this in the market because current competition is already offering winter wear clothing with their own types of high-tech insulation. Columbia currently has a winter clothing line with what they call Zona Field Soft Shell, which is their type of insulation. And Under Armour has their cold gear technology, which is pretty similar to a heat blanket. But nothing that uses this aerogel technology is being implemented in clothing right now. So we think this would be a great opportunity to use this aerogel technology to get a competitive advantage in the market and claim a pretty big chunk of market share from the other revenue from September of this year for just their apparel, footwear, and accessory lines, where ending in September for the previous 9 months, they took in net revenues of 1.6 million in 2013 and 1.3 million in 2012. So the market is definitely there, the demand is definitely there. Now, obviously, going into a seasonal industry like winter clothing, sales are going to be higher in the winter months. But we can see that here over the past 4 years, clothing has stayed pretty strong. There hasn't been a dip in sales. Again, this just shows that that the sports and outdoors industry is strong, it's growing, and there's a definite demand for improved technology like this aerogel insulation.
Hello, my name is Richard Gavishausen, and I will be presenting the third and final part of our presentation. First off, I will be talking about the implementation into target industry. We will be looking to license this technology to sports and outdoors retailers rather than develop our own brand of clothing and or products. We feel that strategically this is our best option since there are so many different uses for this technology that don't include the sports and outdoors industry. It's also a very crowded industry. So potential buyers and target companies of our technology are Bass Pro Shops, Dick's Sporting Goods, Cabela's, Academy, and Gander Mountain. The potential use for our technology in the sports and outdoor industry are to insulate clothing. Aerogels can provide insulation clothing without being bulky like current winter wear. The temperatures that aerogels could withstand would be greater than any product currently available in the market. Lightweight supplies. Camping, hiking, and outdoor supplies can be made with an aerogel plastic combination that is lighter than all products currently available. When camping or hiking, you are forced to pack a lot of different products that can become quite heavy. So having a sturdy backpack that weighs nearly nothing would be an amazing benefit. Protective clothing. Hiking boots and gloves could be incorporated with the aerogel to add protective strength to aid campers and hikers. Campers and hikers never know exactly what they are going to face while on their adventure, so having a pair of boots that can protect you from a snake bite can end up saving your life. Projected implementation of patent technology. From a business standpoint, development of multiple types of clothing winterwear would be a difficult industry to break into. Licensing the technology to companies who already make a particular product would be the most profitable strategy to implement. And also would be a lot easier. Price structure of technology. Fees and royalties for the proposed price structure are difficult to set in stone. Typically, licensing fees usually range from a few $1,000s to a few tens of thousands of dollars. Royalties can range from less than 1% to somewhere around 10%. But if there is a clear commercial application and a large potential market, as there is with this aerogel technology, larger fees can be negotiated. Strengths of the sports and outdoors industry is fairly strong. The patent technology in consideration is also very strong. Still, there is work to be done with this technology, which could hold back investors. Investors are usually looking for a proven product that they know will return their investment. With this technology, finding the right investor who sees the potential in technology is a must. A reasonable price structure will consist of a license fee in the range of $40,000 to $50,000 per product, and a royalty fee to 7% of cells. Manufacturing and marketing. An advantage to licensing this technology is manufacturing costs will be kept fairly minimal. Once ready for distribution or combination with another product, the licensee would be responsible for the rest of the manufacturing costs as they develop a commercial product for sale. This is a great advantage to the inventor of this technology. There are a few challenges marketing this aerogel technology to potential buyers face. Thomas Sullivan has stated that this technology is about halfway through its development for a commercial product, which could drive away some potential investors who are really looking for that final product. If the cost to bring this aerogel to market proves to be very high, then other areas of the budget will have to be cut back, most likely the advertising and marketing budget, which could be very drastic because if you're not able to get this out to the investors and all the different companies, you really don't have anything. Challenges. Companies are very risk averse, especially when it comes to new technology. Companies like to invest in proven products that will generate a return on their investment. In this marketing route, we develop prototypes of the product in use to demonstrate the thermal insulation, lightweight, and increased strength of this aerogel technology. Some possible prototypes. Ski jackets that are more insular and half as bulky as products currently on the market. Thermoses that weigh nearly nothing. Hiking boots that can withstand the weight of a boulder. The possibilities of the number of prototypes that can be used with this technology are endless. We believe that prototypes that are developed and demonstrated could prove to be a huge success that would attract many investors and many buyers of this technology. In return, the expected return for the company licensing this technology will be slow but steady. Once the research and development costs are paid off, the return will be mostly profitable. Challenge will be to find enough companies to license the technology to get past the initial cost. Early adopters of this technology will be the best marketing investment. Closing remarks. So we found a great quote that we believe resembles the future of this technology perfectly. The overall point is that new technology will not necessarily replace old technology, but it will date it, by definition. Eventually, it will replace it. But it's like people who had black and white TVs when color came out. They eventually decided whether or not the new technology was worth the investment. Steve Jobs. This is a great quote that really relates to our technology. There are products out there now that do exactly what this technology has the capabilities to do. We just believe that this technology is better and more innovative than current products. As technology develops, companies must meet new technology with open arms in order to survive in an ever-changing marketplace. Everyone's always looking for the new better, new. Everyone always wants new. In order to meet changing demands of the market, clothing companies will need to embrace new technology to give consumers a new experience. Nanoencapsulated Aerogels will prove to be an extremely versatile new development that can bridge the science and everyday life. The implementation of this aerogel into winter wear clothing is only the beginning. Basically, anything that is insulated, this technology can be used for. This technology can be used in appliances, houses, cars. The possibilities are really endless. I will now open it up for questions and comments from the audience.